The presentation you're going to see here this morning is presented by Hilti. Hilti is a partner with the Steel Erectors Association, a great sponsor. We have a rebate program with Hilti through SEAA that I think this year, as I understand the numbers, are going to return somewhere in the neighborhood of about $16.5 to our association through the sale of Hilti anchors and their deck attachment systems and all the great products that Hilti has to offer. Doing the presenting this morning is Bernard Cruz, PE, with Hilti, and you're out of Tulsa, and Vince Smith, also a PE. Very cool, and you're out of the Carolinas. So I'm going to turn it over to these guys on proper installation of anchor systems. And thank you, guys.
Thank you. I'm pretty wired up here today. They got 2 mics on me so you can get me on the camera and everything. Like you mentioned, my name is Bernard Cruz. I'm the product manager of chemical anchors for Hilti in North America. So what I do for Hilti is I do a lot of market sensing. I also work on product development. So I'm very heavily involved with the development of chemical anchor systems, how we test them, how we develop them, our technical data that we present to you guys in the field so that you guys can make proper decisions on what to use in the job site and how to use it. So that's what I do for Hilti. Let me kind of get this started here. So what we're going to talk about today is we're basically going to do a shortened version of what we call our basic anchor installer training program. Hilti does a free training program all over the country for installers on the job site or at your offices, where we do basically this theory portion that we're about to do. And the part that I cut short for today, because we can't do it in here, is the hands-on installation portion. We're going to do part of that, but what we actually do on the job sites is we actually do a 1 to 2 hour training for installers on the job site. They get this theory portion you're about to get, a hands-on portion, and there's also a written test that I'll give you guys the option to take yourselves as well. And if they successfully go through the program and pass the test, we actually give them a card. So that way you know that your guys, or if you're on the job site, you have subs working for you, or your guys say they know what they're doing, we actually give them a laminated card that shows they've been trained by Hilti, and that's kind of what we're going to go through today. Okay? So we're going to go through some general adhesive anchor information, proper installation. Okay, so we'll talk a little bit about that, and selecting the right anchors. Okay? There's a couple of things that go into the successful use of anchors on a job site. Okay, obviously the engineers are going to give you guys specifications to follow on the job site, and there may be engineers in the audience as well. But you have choices in general, because I come from the design community, and I know from my background that in general specs have a little bit of flexibility. So they'll say something like use product X or an approved equal, or there will be a specification that gives you basic requirements to follow, and you're allowed to basically make a choice on the job site. So I'm going to kind of give you a little bit of information on how to select the right anchor systems. And the second part of that equation to successful use of adhesive anchors is installation. Okay, so we're going to talk about that a little bit more in depth. There's a little bit of an application quiz, so I'll show some photos of some applications from some job sites, and I'll kind of quiz you guys on what product you should use for that, or what type of product you should use for those applications. And we'll do about a 30-minute hands-on session. So I'm really going to only talk to you guys for about 20 or 30 minutes, and we're going to do a little bit of hands-on here. Okay. This is a pretty light program, so meaning I don't have a whole ton of slides, and I'm not going to bore you to death with slides. I like to keep these things pretty informal. Okay. I'm here to teach you guys something, and try and pass on whatever I can, and hopefully you guys learn something. And the best way for you to learn something from me is to feel free and ask questions at any time. Okay? All right. Just a little bit more background on myself. Like Chip mentioned, I'm an engineer, and I've been in the industry for a while, close to 10 years. And interesting enough, how I came to being is pretty interesting. From the time I graduated from college and I started working as a young structural engineer, I actually worked for a guy in Southern California who was a local expert in foundation and anchor bolt design. Okay, so somehow or another, I ended up working for this guy, and my design background, I did a lot of steel design, I did a lot of petrochem work, but one area that I focused on very heavily was foundation anchor bolts. Okay, so I worked in the design community for a few years, and then I've been with Hilti for about 6 years now. And my entire time with Hilti, I've been working with anchors. So basically, for the last 9 or 10 years, I've been doing anchors and anchors and anchors. That's really what I've been doing for the last few years. So, and that's my background. So I have a pretty good understanding of what goes on in the job site. Like Vince here, I was a field engineer when I first started with Hilti, and we spend a lot of time on job sites with contractors and engineers, oftentimes trying to solve problems. So let's say you guys come across a situation on a job site that you can't figure out how do you attach this steel beam to this base material or this wall. You're not sure about it. That's where our field engineers come in. That's what I did for a number of years with Hilti. So I have a lot of field background, and I do a lot of training. So, okay, let's get started in here. Before I get started, I just kind of get an idea of who's in the audience. Do we have any engineers in here? Okay, and I guess I'm assuming the rest of you guys are in steel erectors. Okay, good. So I'm talking to the right people. Now, are most of you on the job sites, or are you more like the managerial supervisors, superintendents, and that sort of? Both, all around. Okay, good. Because there's some topics that, for example, some owners and superintendents come to me and ask a lot about liability and stuff like that. So I just want to make sure I address everything, whereas most of the guys on the job site, they're really more interested in just what they're doing on the job site. So, okay. So this is the first concept I want to talk about. Now I talked about this at last year's meeting. Adhesive anchors are a system. Okay, it's kind of like a car. So if you think of a car, there's many factors that go into a car to make it fast, right? So you can have a great engine, but what happens if you have cheap tires? Are you going to be the fastest car on the track? No. Okay. So you can have a great engine, and if you don't have everything else to go with it, you're not going to win races. Same thing with anchors. So when you think about anchors, there's a lot of things that go into the actual performance of the anchor. Okay. So obviously one thing that people focus in on is with an adhesive anchor, people focus in on bond strength. Okay, that's great. Okay, bond strength would be like the engine of a car, but if you don't have everything else with it, then you really don't get the loads or the performance that you need. So some of these other factors that go into the performance of an adhesive anchor system would be something like cure time. Okay, so that's a pretty important factor. So does the anchor cure, and can you load it and torque up your nut and washer on that steel plate within an hour? Or there's products out there that take 72 hours. Okay, sometimes that's dependent on the temperature. Okay, so if you're working here in the wintertime, okay, your cure time for one product may be X. Okay, and if you're using that same product in the same job site 6 or 7 months later, the cure time of that product may be half, or even a third or a quarter of what it was. Okay, so that actually affects your working schedule, but it also affects a couple of other things. If you torque up that nut and washer too quickly, you can actually break the bond of that anchor. Okay, or if you don't get the anchor in fast enough, it could potentially start curing before you put the rod in there. Okay, and you'll never get that bond that you need. Okay, so that's how it affects the performance of the anchors. There's also creep resistance. I think we overheard somebody mentioning earlier that they had some anchors installed to a ceiling. Okay, creep resistance is directly related to something of that nature. Okay, what creep is long-term deformation of an anchor. So if you're hanging something from the ceiling, some anchors have great creep performance, meaning that when you hang a load from that anchor, it's not going to slip out much over time. Okay, all anchors will creep some. Okay, but the difference is, does an anchor creep a millimeter a year, or does it creep an inch a year? Okay, then what's acceptable to you and your construction? Okay, is a millimeter a year acceptable, or 0.1 millimeters a year, or can you live with an inch? Okay, And that differs based on the adhesive anchor system you choose. Okay, then you got installation procedure, which we'll talk about. Temperature sensitivity. Okay, talked about temperature when you're installing it, but also over the life of the anchor. Okay, so that's another differentiating factor between products. So if you're installing an anchor in an area that's very warm, okay, that could affect the actual performance of the anchor. So you've done your due diligence, you've picked the right anchor, and you've installed it at the right temperature, but that anchor is being installed next to a heating unit, okay, where the concrete gets very hot. Or let's say, okay, I'm from Southern California. Let's say you installed an anchor in Palm Springs, okay, where the temperature can actually be maintained at 110 degrees over several days. That can affect the anchor performance. Okay, so these are some factors that go into the actual performance, the ultimate performance of the anchor. Okay, so I guess the point I'm trying to drive home here is that it's not just about the loads. So how many of you guys have seen technical data from anchors and seen an allowable load table? Okay, that's just one small piece of the actual end performance. So you can actually have an anchor that has a very high published loads, but these other factors may diminish that in the long term. Okay, you guys clear on that? Good. All right, so this is just kind of my analogy of bond strength in the engine. Okay. Now hole cleaning. Okay, so you can have a great system with a high bond strength, high temperature resistance, and all that good stuff, but is it going to help you if the anchor's not installed properly? Not a whole lot. I mean, I like to draw an analogy to a car. Okay, you can have the best tires, the best engine, best suspension, all the great components you want, but if the mechanics don't know what they're doing, they don't put the car together right, are you going to win a race with that car? Probably not. Okay, so same thing with anchors. Okay, and you guys are all construction professionals. I feel that, or I guess that probably goes for everything you do. Okay, if you don't put stuff together right, it's not going to do the job that it's intended to do. Okay, no different with anchors. Okay, so it's important to have clear instructions. Okay, and I guess this didn't update this particular thing, but this is what our installer training program is intended to handle. Okay, so we're here to help with that installer piece. Okay. All right, so I'll pause that for a second. So how many of you have actually seen adhesive anchors installed on a job site or have done it yourself? Okay, good. So we got some pretty experienced people here with this. How many of you have seen these little blowout bulbs? I'll let the video play here. Have you guys ever seen these things before on the job site? Okay, I see some heads nodding. Yeah, so this is what we call manual cleaning. So this is a manual blowout pump, and it's used to get the dust out of the hole. Is this a process you guys are pretty familiar with and seen on the job site? Yeah. Okay. All right. So what we're going to do in this video is actually we're going to compare this cleaning method to what we call a compressed air cleaning method. Okay. Now just pay attention to how much time these two processes take. So now he's using an air compressor to blow out the dust from the hole. And that's a brush, a wire brush. Brushes it out twice. Now, do you think there's going to be any difference in the cleanliness of the hole between these two cleaning methods? Okay. How many of you think that there's going to be a very big difference? Okay. And we'll take a look at that here in a second. So we actually have two blocks that we clamp together and we drill down the center of them so we can see the cleanliness of the holes. And that hole on the far left is actually an uncleaned hole. So you can actually have a reference point as to what it looks like when a hole's not cleaned. All right, and we'll get a zoom in here in a second. Okay, so that hole on the far right there is actually a hole that was cleaned with an air compressor. All right. Now, I guess the point of this is that, do you think, let's take the air compressor cleaned hole versus the other two holes. You think you're going to get the same bond strength out of that hole? No, probably not. Okay. I mean, so why is, yeah, go ahead.
I'm sorry, yeah, but the one in the middle is what done with a pump
Mhm.
that we can get from you, right?
Yeah.
That is designed, so that would be sufficient to get maximum strength?
That would be sufficient to get maximum strength for a shallower hole. Okay. This isn't part of this presentation, but since you brought it up, that's a very good point. The building code now, the 2003 and 2006 IBC, is very strict in how you publish your instructions for your product versus your loads. Okay. So the instructions that are supplied with the product are now required to be exactly what was done in the laboratory to get the loads that you're publishing. Okay, so the product that you have, you need to read the instructions is the point. Okay, so we have older systems that we developed with that blow pump cleaning method, and the loads that are published for that system are with that cleaning method. Okay, now under the new building code, okay, you actually can test to very deep embedment depths. Okay, and once you get past 10 inches, that blowout pump really doesn't do you any good anymore. Okay, that's one of the things. So under the old code, we only had to test to shallow embedments and then publish those loads for you guys to use. And under the old building code, since we didn't have to publish those deep embedment depths and give you loads for that, we felt, and our instructions were that blowout pump. Okay, now under the new building codes, we can publish embedment depths up to 20 times the diameter of the rod or the rebar. Okay, now when you get to that range, the blow pump doesn't do you any good anymore. Okay, so basically, up to 10 inches of embedment depth and a 3/4 inch diameter hole, that blowout pump will do you fine. Okay, and our loads reflect that.
On adhesive anchors,
Mhm.
is it more or less important with cold temperatures for cleanliness? Because I've always been told that the warmer the temperature, you have a more rapid cure. But with the cleanliness of the drill hole, is it more critical with colder climates than warmer?
Okay. Did everybody get that question? You want to know if it's more critical in cold or hot climates to clean the hole? The short answer to that is it's important in all temperature ranges to clean the hole. Okay. What the temperature does is that it affects the cure time. Okay, that's all it does. But whether you're in hot or cold weather, keep thinking about that dust that you see on that hole. Okay, it's going to keep that bond from happening perfectly. Okay. Again, I'll draw another car analogy. If you paint your car without cleaning it, what's going to happen to the paint? It's going to chip off. Okay, very similar to adhesive anchor systems. If you don't clean the hole right, and you don't have that hole condition on the far right, where you don't have a layer of dust on the wall, you may not get the full load value. Okay, now, but again, going back to the new building code, since we can publish deeper embedment depths, okay, we have to publish a installation instruction that will give you the full value of that anchor at those deep embedment depths. Okay, so what you'll actually see for all anchors tested under the new building code is that the installation instructions actually require you to use an air compressor. Okay.
So the center hole you get acceptable bonding strength is that center hole?
Well, let's say you get what you get. So if you publish in your instruction manual that cleaning method, you test it with that cleaning method, and you get the loads that you get. Okay, that's kind of the point of the new building code. Under the old building code, okay, so anchors that were tested to be compliant with the 2000 IBC or the 1997 UBC or any other previous code, you can actually, in the lab, test your anchors with an air compressor and publish whatever you want for the installation instruction that gets handed to you guys. Okay, nowadays, under the 03 and 06 IBC, that's a major no-no. Okay, so if you publish whatever you publish or whatever you do in the lab, you have to publish. You have to give that to the installer, and the installer has to have enough information to replicate what was done on the job site. Okay, that's new in the 03 and 06 IBC. And that's kind of why I guess we tend to push structural engineers to specify anchors that are tested to those new codes, because there's a little bit more confidence there. Okay, so what you guys see on the job site for the installation instructions, you can feel confident now that that's what was used to develop the loads that you're expecting to get. Okay, is that pretty clear? All right. All right, so I guess that's just another close-up of it. All right, so we talked about anchors as a system and the installation, okay? Do we have any other additional questions at that point? Because we're about to move on into the product selection piece. Oh, yeah. When it comes to cleaning a hole, okay, with the compressed air and the wire brush, we kind of try to simplify it with all of our products for the new building code, so we kind of came up with a catchphrase. Okay, if you look at the instructions of any of our products tested for the 03 or 06 IBC, the instructions say blow it out twice, brush it out twice, and blow it out twice. Okay, so I mean, the silly catchphrase we have at Hilti is 2-2-2 is the right thing to do. So that's a really easy way to remember that you're doing it right. Okay, because if you go back to the anchors tested under the old building code, who knows what you're going to get? You have anchors that say compressed air, that say blowout bulb, or it says compressed air for this diameter range. You have all kinds of stuff. But our new products, we kind of simplified it so that we can say, across the board, if you do 2-2-2 with compressed air and a wire brush with any Hilti product, you're good. So you always know that that method will get you the full strength that we publish. Okay?
You said you want structural engineers to reference it. What do you mean by that? Because usually when we do it, we just say install per manufacturer's width.
Yeah. Okay. Well.
Enough or you want more?
Okay. Did everybody get his question? Can you repeat it again so everybody can hear it?
He was just referencing like what the structural engineers have to do. So basically, when we specify Hilti product, we just say install per manufacturer's width recommendation.
Yeah.
Is that enough or you want more?
No, that's fine. So saying that you install it, his question was, as an engineer, is saying install per manufacturer's instruction, is that enough? Yeah. Okay, as long as the anchor you're specifying is compliant with the 03 and 06 IBC, then at least as an engineer, you know that what these guys get in the field gives them enough information to get the performance that you're expecting. Okay. Now, if you said that under the old building code for products tested under the old building code, you're actually not even sure if the product that gets to the job site even has instructions with it. Okay, because that was not required in the old code. So old products, I'll be serious with you. I've seen products that show up to the job site qualified under the old building code that have 4 little pictures with no text underneath it. I mean, so how is a guy on the job site really supposed to know how to install that anchor? Okay. In addition, I'd see products that show up on a job site that don't even have a table that references the cure time versus the temperature. Okay. Now all that stuff is required. So as long as you're specifying an anchor that's qualified under the new building code, you know that what these guys get in the field has enough information for them to do the job right.
All your new products qualified under the new building code?
We still have old products that are still in there, but every new product that we bring out, yes.
2008 Hilti catalog.
Yeah. And actually, it'll say next to the product whether it's compliant with the new building code or not. Because, again, we still have some of the products that we had for the old building code because some projects still require it because they were permitted under the old codes. But if you want to reference a couple of products, it's RE500 SD, which is our slow cure epoxy we'll talk about in a second, and HY150 Max. So we'll get there. Okay? Yeah.
With the 2-2-2 thing.
Yep.
You don't have any compressed air on the job.
Okay.
That hand pump that you guys have, you use that, then oil brush it twice and do that again?
Now that'll only cover you if it depends on the diameter of your hole and the embedment depth. If you're 3/4 diameter and 10-inch embedment or less, you're fine there. Okay. If you're anything bigger than that in diameter for the hole diameter or deeper, you've got to get a compressor out there. Because anything bigger than that, those blowout pumps, they just simply don't create enough air pressure. Quite honestly, all you're doing is you're pushing more dust down to the bottom of the hole because it doesn't have enough pressure to actually push it out. Okay, so anything deeper than 10 inches or bigger diameter than 3/4, you need to be using a compressor. Yeah.
Is the air quality coming out of the compressor affect?
Yeah, yes, that's a good question. Does the air quality coming out of the compressor affect the performance? Yeah. You need to make sure that they're using an oil-free air compressor, because there are some compressors out there that do shoot out oil with the air. Okay. Anything else? Alrighty. Selecting the right system for the application. So this is what we call our Hilti HIT, which is Hilti Injection Technique portfolio. Okay. These are all of our chemical anchor systems. For your structural type applications, you're really going to be focusing on the top half. That's what we call our specified applications. The products on the bottom, that's typically for your ornamental stuff, light duty stuff, ornamental iron. What you're going to be using for your steel beams, your columns, is on the top half. Okay, so we try to make this a little bit intuitive to help people visualize what product they need to use. So on the left side here, you have products for hollow base materials, and on the right, you have products for solid base materials. Okay, and on the solid base materials side, we have two product sectors, fast cure and slow cure. All right. So I'm going to do my best here to kind of to try and educate you about when you use what. If you're in a hollow base material, the choice is pretty simple. Okay, you're not relying on bond strength as much as you're relying on the keying action in a hollow base material. So use HY20. Okay, that's pretty simple. Now it gets a little bit dicey in the solid base material side because you have two types of products. You have a fast cure and a slow cure. Okay. Fast cures are typically not epoxy-based products. Okay. Now, I bring that up because I've spent many hours and days on job sites where I'll hear people incorrectly refer to an adhesive as an epoxy, and I normally don't say anything, but there's some grave errors, I guess. Right? That's just it's very important that people understand the difference. Epoxy type anchors they're an organic based compound. Okay, they're typically slow cure adhesives. Okay, and being slow cure adhesives, they tend to have very, very high bond strength. Okay, however, on many job sites, I can tell you from our own sales mix, people tend to prefer the fast cures. Okay, for obvious reasons. At 68 degrees Fahrenheit, when the base material is 68 degrees, the slow cures take 12 to 24 hours to cure. Some of them can take even 3 to 6 days. Okay, I know of one product that takes 72 hours to cure, and if the hole gets damp because of rain, it takes twice as long. Okay, so you have a 6-day cure time. But slow curing times are reminiscent with epoxies. Okay. And what that does is it allows the epoxy to really, really form a strong bond with the concrete. But again, that's the small segment of the market. Most of our customers opt for the fast cure. At that same base material temperature, HY150 Max cures actually in 30 minutes. Okay, so you can get your full load, you can bolt up your anchor in 30 minutes. So obviously that tends to be a very popular product in the market. Okay. And it's not just on the Hilti side. Most of our competitors, actually all of our competitors that sell the fast and the slow cure, fast cure is by far their most popular product, okay, for obvious reasons. Now, what are the downfalls of something like a fast cure? Any guesses? Yeah.
You got a guy go under a ladder 3 or 4 different times, uses your dual heat gun there, puts the base in there, shoots 3 or 4 holes, puts the connection. Sometimes that tube starts curing before he's done 6 sets of ladder setups. But the customer, I mean, you make a great product, really.
Yeah.
Really does what it is. But sometimes when my customers furnish this material for us to install, I end up using twice the amount of quantity because I'm doing what's supposed to be done.
Yep.
But you can't just do 4 holes and then 4 holes.
Yeah, so there's a work process difference there. And he actually brought up a really good point with fast cure chemicals. Okay, remember how I told you guys earlier that the temperature can actually speed up the cure time? Okay, Max takes 30 minutes secured, 68 degrees Fahrenheit. I know it gets a lot warmer here. Okay? When it gets warmer, you're looking at 15 minutes. Okay, so what he mentioned earlier, when one of his guys would go up, fill a hole, he can't go back down and get the rods to put them in there. Okay, by the time he goes down and comes back up, that material will start to harden. Okay, that's very, very important to understand. Okay, as a field engineer and as the product manager, I've been to many job sites where I get called to investigate something that went wrong. Okay, misunderstanding of cure time and gel time is a big cause of many errors on the job site. So has everybody heard the term gel time? Okay, so gel time is the time that you have to work with the anchor. Okay, the gel time begins from the time you squirt the stuff out of the tube. Okay, that's when the gel time starts. So what you'll typically see in a cure time table is you'll see at 68 degrees the gel time is 5 minutes and the full cure time is 30 minutes. Okay, so what that means is you have 5 minutes to inject the product into the hole, get the rod in there, and you can wiggle it around. And then at 30 minutes, you can load the anchor. But in between that 5 minutes and 30 minutes, you can't touch that anchor, because that's when that bond is starting to occur. And if you mess with that anchor in that time frame, you can actually break the bond. Okay, is everybody clear on that? All right. So when would it be a good time to use a slow cure?
Again, when you have a lot of repetitive connections to make, go ahead and make the connection, insert the bolt or the anchor, come back to the connection at some delta after that.
Mm-hmm.
And that's the beauty of, I think, adhesive anchor, is that it's generally a better bond than expansion anchor. But also, even a quick cure time, you're gonna put the adhesive in the hole and hold it. You have 15 minutes to half an hour for a guy to make a connection.
Yep.
And in today's market, we don't have that kind of time to
Yeah.
address this, and maybe looking at a slower cure, as the answer as opposed to a quick cure.
Yep. How about when it gets warm? Would it be a better idea to use a slow cure in that time? How about deeper holes? Okay. Now here's another difference between the epoxies and the non-epoxies. Most epoxy-based products aren't as sensitive to water or damp holes. Okay. Epoxies actually really bond to the concrete, whereas fast cures, they bond to the concrete, but they also rely on the rough surface of the hole. Okay, so carbide tip drill bits versus diamond coring bits. Okay, are you guys familiar with diamond coring bits? You guys seen those out there? They leave a smooth hole. Okay, so there's no friction in there. There's no rough surface. Fast cures really need that friction. They need that rough surface in addition to the bond strength. A slow cure, since it takes a little bit more time and more aggressively bonds to the concrete, it doesn't need that so much. Okay? Any other, yeah?
You're saying when you use like that system that you have that you do the core hole,
Yeah.
and it's really smooth, it's not recommended to use the fast cure?
No. No, you shouldn't be using a fast cure product of any kind, Hilti's or anybody else's, in a diamond cored hole. Yeah?
Something that wire brush not only cleans, but acts as a scrape against the side.
It actually, the wire brushes don't really do a whole lot to roughen the surface. They do a good job of dislodging dust that's on the surface, but it can't roughen it. Okay.
Some solid CMU products are allowed to be 85% solid or more to be counted as solid. And some of your, I guess your products are good for solid base, really working like 85% solid CMU. Is that?
Okay, when I say solid, meaning that wherever that anchor is going, there's base material all the way around it. Okay, so like there's some CMU block walls that are every other cell grouted. Okay, if you're in one of those, you have to drill the hole and figure out whether there's something back there or not. and that'll determine what you use.
Okay, and I guess one thing to pay attention to is some block are actually completely solid, except they allow 85% of it not be solid. It's called a solid block.
Mm-hmm.
So if you drill the hole, it's real subtle if you hit a void or not.
Okay. If you suspect any voids in your base material and you run into one, I would jump to the hollow base material product. Okay. Yeah, I mean, I've been on a lot of job sites where people tell me they have a solid brick wall. Okay. I always laugh because I think in almost 10 years I still haven't seen a solid brick wall in my life. There's always a void in there somewhere, in between the widths, the mortar, vertical joint, the bed joint, or in between the widths, there's always voids. So, okay. All right. So let's kind of test your application knowledge here. So we got a 3/4 inch by 18-inch embed anchor. Okay, which product would you use? And it's a concrete base material. Slow cure. Okay. In most cases, I usually use the rule is that if it's 12 inches or more, use a slow cure. That's my general rule. 1/2 inch by 6, concrete base material. Yeah, fast cure would be good.
Well, that's just been drilled by that.
3/4 by 12, that's kind of on the border. What would make you lean one way or the other? Because this would be what I'd consider right on the edge. Moisture, okay. Temperature. Okay, so if we have customers in Vegas and in Phoenix and Palm Springs. In the summertime, they just completely switch to RD500. They don't even use the fast cures at all, even for a 5 or 6 inch hole. Okay, so he brings up a good point. Temperature, moisture in the hole. If they diamond cord this hole, for example, that would also be another reason to use a slow cure. But in an ideal condition, 68 degrees, rotor hammered hole, would it be okay to use a fast cure? Yeah, it would. This one's pretty clear. 3/8 inch anchor, 4 inch embed. Yeah, fast cure. Let's how about this one? Yeah, it's HY20. That's a hollow base material type product. All right, another clear one. That's solid brick, right? So which product would you use there? HY20, yep. Again, hollow seam block wall, 1/2 inch anchors, HY20. If this were a situation where they told you every other cell was grouted, I'd still I'd probably opt for HY20.
So even if it's a solid, HY20 will still work.
Yeah, it'll still work. You're not going to get the bond strength of HY150. I mean, yeah, you can do it one way or the other. You can use HY150 max in that hollow base material. You're not going to get the strength of HY20 because it doesn't key the same way. Or you can use HY20. You're not going to get the bond strength in the solid
But
portions.
at least you know what you get.
Yeah.
HY20.
Yeah. And if you run into a situation like that, if you're out here in the Carolinas and you call him, he'll go to the job site and tell you what to do. All right. Okay, so that's it for this portion. I think we can kind of cut this off, but yeah.
You didn't show an overhead application.
Did I show an overhead application? That's a good topic, okay. Overhead. Is that going to play a role in decision making? To a certain extent, yeah. Okay, and that's a good point. Another thing that the building code requires now is that all anchors have to pass a creep test. Under the old building code, the long-term creep test, which would be for overhead stuff, okay, was optional. You didn't have to do it. You can get an ICBO report under the old building code without having the creep test done. Okay, because that wasn't required, all right? So, yeah, after the big dig, things kind of changed. All right, that kind of changed a lot of things. But does an anchor know the difference is if it's being pulled from the top or the bottom? No, it doesn't know. Okay, So it's going to make a difference in you selecting a product tested to the new building code or the old building code. That's what's going to be the break point. But as far as if you have a bunch of products tested to the new building code, will long-term load determine what product you pick? No.
Part of the reason I asked that question also, though, is putting epoxy or an adhesive into an overhead hole.
Ah,
You almost have to hold that
that's
bolt in position.
That is a good point. Okay, so when you install the epoxy overhead, okay, and I kind of made a mess of myself doing this test in the lab, but you can use an epoxy overhead, but he's right, a fast cure may be better because you put that anchor in there and the gel time is done pretty quick, so you don't have to sit there with it. Now the other option is you can put wooden wedges to hold it in there or duct tape or something like that, but he's absolutely right on that. The epoxies may leak out.
That procedure on your instructions then.
It is,
I know.
yeah,
And really, ICBM doesn't address that.
yeah,
As far as I know.
yep. Okay, are there any other questions? Yeah, we're actually going to do a little bit of demonstration of a particular tool here, and I'm going to get you guys out of your seats now. So, yeah,
Let me ask one more question.
go ahead.
Is there a,
Installed mechanical anchors, and the top of the anchor looked nice and shiny, but there's still an annular gap there where water and chemicals can get in, and the anchor actually sheared in the middle, in the hole. So when the train went by, I won't tell you which one, so you guys don't get freaked out, but these things would rattle out of the hole when the train rolled by. And they had no idea what was going on. So we actually walked over there, and I grabbed an anchor and I just pulled it right out. And the other half of the anchor was still in the hole. So there are situations where you just don't use mechanical anchors. Now, if you're unsure what to use, I would actually contact your local Hilti engineer, or we have an 800 number and it's answered by engineers all day long. It has to do with the application, so there's really no hard and fast rule. Anything you can do with the mechanical anchor, you can pretty much do with the chemical anchor, and vice versa.
but I'll just throw one more comment to the design people. With the friction or mechanical anchor, you usually go there, drill a hole, put the device in, and anchor it immediately. Almost all your adhesive anchors, from an installer standpoint, there's usually going to be a higher field cost because you go back to the same source connection at least twice. I think it's a better product. I think it's much more durable, practical product. But there is
Yeah.
a little more field installation.
Yeah. If you need to bolt up the fastening immediately, then a mechanical anchor is the clear choice.
This creep rate, does it have any effect on spalling these concretes?
Spalling?
Yeah.
I wonder how that would work. I would probably say not. Because any spalling that's going to occur from an anchor being loaded is going to happen pretty quick. Okay, and creep happens over a long term, so that stress is already in the concrete from the anchor being tensioned over a long period of time. So if any spalling was going to happen, I would say is when it initially is loaded. Yeah, because what happens when we do creep tests is that the displacement kind of goes like that, and it stays constant over a very long period of time. At least a good product does. And this is normally days, or even minutes and hours, depending on the product. But it's pretty quick, and then it flattens out over time. A lot of people don't know this, but when we invented the injectable adhesive anchor like 27 years ago, and when we did, we actually hung a weight from a piece of concrete with that product that we invented, and it's still running. So we actually have a 27-year creep test running in the basement of one of our laboratories, and we have an intern that goes in there every day and takes measurements. So the theoretical model that you'll see in your strengths and materials books for long-term deformation, that curve, it actually fits very closely to what we're seeing in that test. So it's actually pretty neat. Okay? All right, so I'm going to get you guys out of your our chairs here, and we're going to do one last demonstration up here. And it's an injection demonstration. Can we put the cartridges in there? All right. So this is the last portion, okay? And here's what we're going to do. We've only got a few tools, so we're going to set it up on both sides. But what we're doing is we're actually going to simulate injection of the epoxy into a pretty deep hole, okay? And we're going to do it with a couple of different methods. We're going to do it with the manual dispenser and the battery dispenser. And you guys, somebody brought up the creep issue earlier, or the overhead installation earlier. This little thing on the end of the tube here, this extension hose, it's called a piston plug. Okay, and you'll see what it does in a second, but I won't describe it a whole lot because I'd rather that you guys see it in action. And give me some duct tape here. All right, and I need a volunteer. Somebody? Anybody? Who's brave? He's walking up. All right. All right. Yeah. Okay. So just about every adhesive anchor product on the market has two components. So you actually have the resin, that's the stuff we make, and then the hardener. So when you mix them together, they go through a nozzle. Okay, and the nozzle has baffles in it to mix it together. So once it reaches here, it's mixed properly. Okay, so that's actually the reason why injectable systems were invented. Because do you guys remember grout? When people used to use grout for anchors? Have you ever read the instructions for grout? It says you have to put in exactly 10 point whatever ounces of water for every five pound bag, and if this is not right, then you're not going to get the right performance. Okay, so that's why we have these things, because you just put a cartridge in a tube, you pull the trigger, and you get the right loading value. Okay, so let me get this. Give me that, and I'll give you that. Do is I'm going to have you put on some glasses first. There you go. I'm going to have you fill this tube up. So this is a 5/8 inch diameter hole, and it's about 30 inches deep. Okay. So I'll have him fill that up. And then I need another volunteer. So I think you raised your hand earlier. All right. So you're going to do the one next to him. But he's got the piston plug on the end of his. And you're just going to pull the trigger and hold it. It'll pop itself pretty soon. Now what the piston plug actually does, it won't let any air voids form inside the hole, and it actually pushes itself out of the hole. So what you'll see is that it'll actually start retracting on its own.
Oh, it'll push it out?
Yeah, you don't do anything. You see it's kind of coming out on its own now?
Now that piston is the same diameter as the hole?
Yeah, the piston is matched to the diameter of the hole.
So I draw the short end of the stick here when I got this.
Yeah.
That's what you get for going.
Yeah. All right. You can stop now. Press that little thumb button on yours. You can keep going until we see your piston. And somebody else want to try it over here? We got a couple more set up over here. Okay, you can stop now. Press that one.
No.
All right. We'll take a look at the differences between these holes later. Does somebody else want to give this a shot? Look at that.
Yeah.
You know what's happening now, though, anything that's beyond the nozzle here is already cured. Even in the tube.
Well, this is RA500. It's actually the float gear. Yeah, so we'll put this all the way to the back first. There you go. So what does this guy have to do to fill the hole that this guy doesn't have to do? Well, I mean, first squeeze. But when you're filling up a hole and you don't have something like the piston, you're actually guessing as far as how full it is. And over here, the piston does the work for you. It pushes itself out of the hole. Now, when you're injecting epoxy overhead, it's you can put that piston all the way to the top of the hole, and you're not guessing at how fast you have to retract it. So you can stop now.
the nozzle you're using stays a lot cleaner.
Yeah.
You're not using the same-
Why, Jim? Why does it stay cleaner?
I think we could probably get one more out of this guy.
All right.
Somebody else want to try this, or?
You don't wanna try it?
Don't open the oven door.
All right. Well, let's get a couple more done over there, and we'll kind of compare them.
Very good. See it coming out? There we go. Yes.
Thank you.
Yeah, we qualified on both of that. So let's take a look at those over there real quick. Let's see how they look. You guys did a fairly good job. So this is the one done without the piston plug. So can you guys see the air bubbles in there? Okay. This is actually one of the better ones I've seen. Okay.
Way to go, Mauricio.
Right.
Right. Give him a hand. Give him a hand.
You see there's actually a long section here without a whole lot of epoxy. Now, he was taking his time, but he did a pretty good job. And over here, you have a hole that's pretty well full. You don't really see any air voids, okay? There's really no guesswork in there. This one's actually pretty good too, except they didn't start all the way at the end. I mean, it's kind of no guesswork with the piston plug because you just ram it all the way in. Which one do you got there?
Here you can see kind of hollow sections basically. And here, here. So you don't have completely open air pockets, but you can tell that it was filled up, and then when you pull the nozzle out after you have it too full, you kind of have a suction effect that creates some air.
Yeah.
Hollow sections where you can see through
When I
it there.
pull that nozzle out, I got those little air voids. I stuffed a bolt in there. Isn't that going to take care of them?
It'll take care of some of them. Yeah, it'll take.
I'm filling it up with epoxy, but I'm stuffing a bolt that's the same size as that hole in there.
Yeah, you'll get some of them. I mean, if I was allowed to make more of a mess in here, I would have brought some rebar in here or something like that to put in here. But when we do this training on the field, I mean, we'll put rebar in there, and you'll actually see that when you put it in there, even with the, you think you're filling up the voids, a lot of it will come out, and some of those air voids will actually remain. Okay, so the bond strength that you develop in the concrete, it's based on a continuous shear plane between the concrete and the epoxy. So if there's any discontinuity in there, when you thought you had 30 inches, if there's a small void here, you're actually getting that. Okay, you're not getting.
Isn't there also a difference in the size of drill you recommend to use for an expansion anchor versus an adhesive?
Yeah, adhesive anchor holes are oversized slightly, and with an expansion anchor, they're the same. The other danger with air voids is, have you guys ever put a rod in a hole and have some of it squirt out at you?
Yeah.
Okay, that's a sign of an air void.
I was just gonna ask you something with that. With my crew, I usually have them kind of work it in and out so they start to see that come out. Is that not the right thing?
Well, if you're going to see some ooze out, okay? The difference is sometimes when you put it in there, it actually squirts out. If you see anything fly out like that, you got air voids in there, okay? Now, that's one thing that's messy, but secondly, epoxies are very, very, they're very hazardous materials, okay? If they get in your eyes, any epoxy, it's not coming out, okay? It's permanent. So that person, that's why I wear these, okay? But, if you see that happen on a job site, that's a pretty dangerous scenario. For one, you may or may not be getting the bond strength you're trying to get, okay? Because let's take this example for, which one did we look at earlier that has this one, okay? So we're thinking we're getting 30 inches here, but as soon as you start to see air voids in there, okay, we're not really getting that full 30 inches, especially up here. Okay, we're really actually not getting a whole lot. When you put that rod in there, that's not going to fill up the hole. You're going to see rebar or threads touching the edge of that without any epoxy on it. And when you start to see discontinuities in here, like there and there, okay, you're not getting the full load value. So let's say this was solid. He did fill this up, and he only had this one air pocket in there, okay? When you put the rod in there, that may or may not, because the gravity won't actually allow this stuff. It's too viscous. It won't flow. It won't fill up that void. So when you put that rod in there, that air void's probably going to remain. So you actually get this is your embedment depth as opposed to this whole 30 inches. Okay, so these are all, there's safety factors built into the data that we publish, but once you start doing things like misinstallations, there's air voids, wrong installation temperature, you didn't wait long enough to put the product in, the rod in the hole, those safety factors start to disappear pretty quick. Okay, that's why we do this training for people, because somebody brought up the big dig earlier. The industry already had one accident. Okay, that's all we need. All right, that's really all we need. So we do this training everywhere. We have 1,500 people doing this training, and it's free on any job site that you guys are on, or any trailer or your office. Okay, so we'll do this and we'll certify them. All right. Okay. Before I let you guys go, this is optional, but just if you kind of see if you guys are paying attention or for your own fun, this is the test that we actually give to people out on the job site. So if you guys want to grab one and kind of test your knowledge, we have some tech guides here. You're going to need a tech guide or catalog. I'll give you this. You're going to need that as a reference. Bring it to our booth, okay, and I'll grade it. We'll go over it. And if you do well enough, I'll give you a card so that you can prove to everybody that you did the training.